Here's an example of a problem where we've got an interesting pulley system such that the object that is doing the pulling, this gold thing right here, is going to move more than the object that's being pulled as a result. And because the gold thing moves more, it's not going to have the same acceleration because it's going to move a different distance in the same amount of time. As we discussed in our lecture in class, since the gold ball here is suspended just by one string and this is suspended by two strings, noticed that the distance that the gold thing is going to travel is going to be twice as far as the distance that the black thing is going to travel, which means that for the same amount of time of travel, the acceleration of the gold thing is going to be twice the acceleration of the black thing. But before we get fully into those details, let's first just understand what it's going to take to simply balance this system. This is going to apply down here. In order to just balance this, well, let's make free body diagrams of both. So we got the black object, and it has 1 kilogram, so that's going to be, I'm going to call that MBG, and it's got 2 tensions upward, because there's 1, 2 strings, tension, tension. Now, one thing that is definitely true, continues to be true, is that the tension in the strings, since this is one continuous string, goes up and over here, the tension is the same everywhere throughout the system. So whatever this tension is in one string pointing up, that's the same as the tension in this other string, but there's two strings pulling up on this mass, so there's 2 tensions pulling up on that mass. The gold one, I'll do it orange in my orange pen. This orange one has its mass. We're going to find the mass of the gold thing downward, and it is only being supported by 1 tension, 1 string. Well, we know more about the black thing because we know exactly what its mass is. So as far as the downward forces, we've got 2t minus mb G equals 0. We're at rest, we're balanced, so that tells me that 2t equals mBg. Well, we know what the mass of the black thing is. It's 1 kilogram, so that means it's 10 newtons. So 2t equals 10 newtons, so that tells me that the tension equals 5 newtons. All right, that's a very important piece of information, which we can then plug in to figure out what the mass of the gold thing needs to be. So as far as the mass of the gold thing, we've got tension up, and we've got mass of the gold thing down, and that equals 0. Well, now we know what the tension is. It's 5 newtons equals the mass of the gold thing times G, which is 10. So that tells me that the mass of the gold thing has to be 0.5 kilograms. So because the gold thing is supported by 1 string and the black thing is supported by 2 strings, the gold thing is going to need only to be half as massive because it's got 1 string pulling up on it, whereas the other one has 2 strings pulling up on it. All right, well, now let's make them unequal. Suppose the gold circle has a mass of 1 kilogram. So that is going to give us a force downward of 10 newtons here. So we're going to perform the same analysis, more or less, but this time we don't know what the acceleration is. So going into this, we have to recognize a couple of things. 1, the tension. Remember, the tension is the same everywhere. However, the acceleration is not the same for the 2 objects. So just like we always do, we're going to set up a Newton's second law equation for each object and kind of see where that gets us. That's the starting point. Set up a Newton's second law statement for each object. Well, here's the black one. Now, the black one is going to go, as this gold one descends, the black one is going to go up. So I'm going to say that the direction that each one goes, I'm going to call that positive, so that they each have a positive acceleration. Their accelerations will agree with each other. So we've got two tensions upward, and we've got M black, G downward. So since this is going to accelerate upward, I'm going to call that positive. So we got 2T minus M black times G equals M black times A. We don't know what this acceleration is yet. I could plug in some numbers. I could do it now. I could do it later. I'm going to do it now. So we got 2T minus, well, that's 1 kilogram. So that's going to be 10 newtons equals mass of thing is 1 kilogram. So equals 1 times A. So there's our expression for the black thing. We need an expression for the gold thing. Well, this one is accelerating downward. The mass of the gold thing times its acceleration with one tension resisting it. That's going to accelerate downward, so I'm going to call downward positive for this one. So we got mg times A minus tension equals mg times, mg times g, that's its weight, minus tension equals mg times A. Ooh, you know what I should do? I should be specific. That's the acceleration of the gold thing, and this is the acceleration of the black thing, because they don't have the same acceleration. Key point, very, very important. They don't have the same acceleration. So what I'm left with at this point, well, maybe I'll take this one step further, I suppose. That's still the black thing's acceleration. We do know this mass. We said it's 1 kilogram, so it's 1 kilogram times gravity. So that's 10 newtons minus tension equals, well, again, 1 kilogram. So that's 1 times the acceleration of the gold thing. So at this point, we've got a tension. That's the same tension. It's the same string throughout. So we've got the same tension in both equations, but we've got different accelerations. Uh-oh. 3 unknowns. The only way to solve 3 unknowns is to have a system of equations with 3 equations. Oh, but remember, the accelerations do relate to each other. The acceleration of the gold thing is going to be twice as fast as the acceleration of the black thing. So this is going to be a substitution we're going to make. So basically we've got 3 equations. Just kind of set that out. You know, in this sort of a problem, expect that. 3 equations. Ugh. So here's one equation, here's a second equation, and here's a third equation. Just one that relates the acceleration of the 2 objects to each other. We're going to sub that in first, get that out of the way. So the acceleration of the gold thing is twice the acceleration of the black thing. So I'm going to put that into here. So 10 minus t equals twice the acceleration of the black thing. Well, now we've got 2 equations and 2 unknowns. I'm going to rearrange to solve for tension. 10 minus 2 times the acceleration of the black thing equals tension, and now I can sub that into here. So moving forward with the black thing, we've got 2 times the tension, which is 10 minus 2a minus 10 equals the acceleration of the black thing. So 20 minus 4a minus 10 equals acceleration of the black thing, acceleration of the black thing. Rearrange, we've got 5 times the acceleration of the black thing equals 10. So the acceleration of the black thing is 2 meters per second squared. Now we've actually solved for a real value for one of the things, and we can start plugging back into everything else. So let's plug that back into there. So the acceleration of the gold thing is going to be twice that. So it's going to be 2 times 2. So the acceleration of the gold thing is going to be 4 meters per second squared. And if we wanted to, we could then also find the tension. So 10 minus 2 times the acceleration of the black thing, which was 2, equals tension. 10 minus 4 is 6 newtons is the tension. So 3 unknowns, 3 equations, but all in all, very similar approach to everything we've done so far. We're just creating Newton's second law statements for each of the objects. The only hitch here is that they don't have the same acceleration. So our third equation is an equation which relates the 2 accelerations to each other. There we go.